In this video, we're going to be looking at pump calculations, and specifically we're going to be looking at how to calculate the flow rate, the pump RPM, the revolutions per minute, the head pressure, the pump power, and also the impeller diameter. Now, if you already have a pump installed in one of your buildings, then you should have a checklist or a sheet that comes like this, which is the data sheet for that pump. Now, all too often, parts of this design data are missing. And that's really frustrating, but if you have got some data missing, then we're going to look at some formulas of how to calculate and fill in these gaps, and also we'll look to see what would happen if you were to change some of these parameters. Now, of course, if you haven't got the pump installed yet, you're in a design phase, then you can also use these formulas to determine what the performance will be. So these formulas will give us the values of the pump performance curve. Now, do remember that these calculations will only give us theoretical values. The actual performance may vary from these, and certainly the older a pump gets, the larger discrepancy becomes between the theoretical and the actual. So you might need to add on a correction factor to adjust these. But for everyday purposes and for your studies, this is fine. So if we jump into the calculations, you can see first of all that I've split the screen into two parts, being the metric and imperial. So we can look through the calculations for both of these. I've also tried to color code all the figures we'll have so you can follow those all the way through, because sometimes it does get a bit confusing, obviously, chasing these numbers through, so that should make it a little bit easier. So for this calculation, this is we're going to find out what the new flow rate would be if we were to increase or decrease the pump revolutions per minute. And to do that, we're going to use this formula here. So we've got the flow rate. The new flow rate is equal to the revolutions per minute, the new one, multiplied by the division of the old flow rate divided by the RPM of the old system. So if we drop the figures in for there, we can see that originally the pump will have 57 liters per second, and we've got the adjusted RPM and the original RPM. These are the same. I've done in the imperial in gallons per minute. For the metric, I will just point out that I've used liters per second here. It should really be meters cubed per second, but almost always the pumps are listed in liters per second. And it doesn't particularly matter about this, the units you use. The units you put in are the units that you're going to get out. So you can change it to meters cubed per second or kilograms per second, and it will come out the same. Just, remain consistent throughout. But anyway, if you do the calculations for these, then you'll see that this comes out to 52.6 liters per second, or 833 gallons per minute. So the next one we're going to look at is the new flow rate, and that would occur if you were to change the impeller diameter. Now, we'll point out that this isn't an older way to do this if it's already existing, to actually trim down the impeller to change its diameter. It's not the preferred way anymore, and that's because once you trim it down, you can't obviously add that material back on, so you need to replace the entire impeller. A much better way is to actually use a variable speed drive or a variable frequency drive to change the speed of the pump to meet your design criteria. But if you are looking to change the impeller or to even trim the impeller down, then you can use these calculations here. So for this one, the new flow rate would be equal to the new diameter of the impeller multiplied by the old flow rate divided by the diameter of the old impeller. And if we drop those figures in, then we're going to come down, and that you can see comes to 52.6 liters per second, or 833 gallons per minute. Now the next one we'll look at is the pump RPM, the revolutions per minute. So if we were to increase or decrease the flow rate, what RPM would we need to achieve that? And we can use this formula here to find that out. So the new RPM, revolutions per minute, equals the old RPM multiplied by the new flow rate divided by the original flow rate. And if we add those figures in there, you can see here that these two units of measurement cancel out, and so that leaves you with a ratio or a percent. And so you multiply these out together, and that will bring you down to 1,300 RPM. So that is the speed that the impeller needs to rotate at in order to achieve this new flow rate. So the next one we'll look at is how to calculate the head pressure, and this would occur if you were to increase or decrease the revolutions per minute of the impeller. And to do that, we can use this formula here. So the head pressure, the new head pressure, is equal to the RPM of the new revolutions per minute squared multiplied by the old head pressure divided by the old revolutions per minute squared as well. Now pay particular attention to this one and make sure you square both of the RPMs. All too often people forget to do this and the numbers, they just come out horrifically and it's very embarrassing. So obviously make sure you double check that. You'll also notice here that I've written these numbers out in full. Really you should put these in standard form, but I've just put these out so you can see them very clearly, what the numbers are and how we get to this final figure here. But if you're doing this for work or in an exam, etc., then put them into standard form. But anyway, if we drop the numbers in and work our way through these, then we'll come down through these very large numbers all the way until we get to the new head pressure, which would be 364 kPa or 122 feet of water. The next one we'll look at is also head pressure, and that will be how to calculate this. Should you increase or decrease the flow rate? And we can use this equation here, this formula here, to calculate that. So the new head pressure is equal to the old head pressure multiplied by the division of the new flow rate divided by the old flow rate, and make sure you square the number you get from this division as well. So if we drop some of the numbers in there, and we can see how this plays out. Also remember, like I said, to do the division and then square this number here, so you get this out, and then you get to your final number, which is just your ratio or percent. And drop these in, multiply them out, and you'll see you come to 364 kPa or 122 feet of water. So the next one we'll look at is the pump power, and that will be how to calculate what the new pump power would be should you increase or decrease the revolutions per minute of the pump, or from the motor. And to do that, we can use this equation here. So the new power is equal to the RPM, the new revolutions per minute, cubed, multiplied by the division of the old power, divided by the RPM, the revolutions per minute of the old, cubed that as well. So if we drop the figures in for there as well, then you'll see this will all come out like this. Again, I haven't written these out in standard form. You should do, especially if you're going in for an exam, you're taking this data in with you. Make sure to put it in standard form, but I've just written these out in long form just to make it very clear what the numbers are and how we get to these final figures. So you can see if you, to calculate all these, remember to cube these numbers as well. Obviously that's why they are so long. Make sure you do these as the first step, otherwise you might lose it and then you'll mess up all your calculations, so don't fall into that trap. So if we calculate all this, and you'll see it comes down to 35.4 kilowatts, down from 45 kilowatts. And on the Imperial side, it will come down from 60.35 horsepower down to 47.5 horsepower. And the last one we're going to look at is the impeller diameter. So if you were to adjust the flow rate and you wanted to achieve this new flow rate, what diameter impeller would you need? And this is usually used in the case where the impeller is being trimmed down to meet a new flow rate. And so that's what I've done in the calculations here as well. You can see that originally it was 57 litres per second or 903.5 gallons per minute. And the new flow rate, which I want to achieve on the metric side, is 52.6 litres per second or 833.7 gallons per minute. So if we was to drop those numbers in and start doing the calculations, you'll see that these two, the units of measurement, cancel out, and that becomes a ratio or percent. And if we multiply that out, or put them both together, then we will come down and get the final answer of 184.56 millimeters diameter, or 7.26 inches.